General, distinguished guests, ladies and gentlemen, thank you very much for inviting me back to speak again. It's a pleasure to be back here in India. I'm always impressed by the vision and leadership shown by the senior officers, and really that's where it starts in implementing any new technology, any new doctrine. On my first visit, I thought it was because you had very good staff officers who wrote very good briefings, but it's clear to me now that actually by the delivery of the presentations, the senior officers do actually understand what they're delivering, and it's very refreshing to even hear the GOC, CNC talking about NSDI. Chris Tucker and I were joking at the break that we don't think a US general could even spell NSDI, with apologies to my US colleagues in the audience. Soft missions, Special Operations Forces missions are clearly very sensitive, and it would be very difficult for me to talk from the specifics, and I'd like to thank the previous speaker who's done a very good job, I think, in terms of explaining the feature functions that GIS can perform. So my presentation is going to be a little bit higher level. It is informed by my experiences in Northern Ireland with UK Special Forces, Special Air Service, also in Bosnia where we supported the NATO Special Forces, and since joining Esri and leaving the military, I've had the pleasure of supporting a number of special forces organizations around the world, not only the US, but in other countries. So there is some context and some background that I think I can bring to this discussion. Special forces do operate, obviously, in very sensitive missions, and they do operate as very small forces. But they also operate in support of conventional operations. And as the GOC&C said this morning, we may have to not only fight asymmetric warfare, and we will probably have to use our special forces in support of kinetic operations. So I don't think we can lose sight of that. One of the most valuable things that I think GIS brings today is not only the feature functionality of analysis, but it's actually three main areas of integration. The first is the integration of multi-int. It is this integration of all types of information. Geography is the integrating framework, but it's not about the maps. It's about what we can put on the maps. And this is really the multi-int all-source integration. The second thing that GIS does is it integrates people. It brings together different groups. It allows us to bring together our intelligence and our operations and very quickly begin to share information as part of the decision-making process, as the previous speaker showed. But it also allows us to break down the barriers between our organizations. We all have an Army Special Operations Command, we all have an Air Force Special Operations, but we also have a Joint Special Operation Commands. And as was mentioned earlier, in NATO, we actually have a NATO Special Operations Fusion Coordination Center. That's actually in the UK. We also have a Special Operations Joint Task Force Afghanistan, where now in Afghanistan all Special Operations Forces from the whole of the coalition come under one coordination center, because if we operate in complete secrecy, we have fratricide. I actually saw that in Northern Ireland, where Special Operations Forces actually ended up attacking conventional forces because their missions weren't shared. So in this highly dynamic area of special forces, we need to provide this integration, and we need to do it rapidly. The next thing I want to talk about is integrating the types of information beyond maps. To me, GIS, it already does imagery, it already does vectors, it already does rasters. They are a GIS. We don't have separate systems to handle separate data. And increasingly now, it's not about the maps, it's about all that other intelligence. And let me just highlight a few of them. Social media. If you want to understand what people are doing in your area of operations, social media is the best way to do that. So yes, we will operate on the internet because that's our open source of intelligence. And I don't need to remind this audience that the first open source of intelligence about the assault on Abbottabad to take down Osama bin Laden was actually a tweet. And so special operations forces need to be monitoring Twitter, they need to be looking at Flickr as another source of intelligence about their targets. Sensor networks are an incredibly important part for chemical, biological, radiological, nuclear, or other sensor information that now needs to be brought in as that highly dynamic information that's going to inform our decisions. We now understand that GIS can do imagery, but it can do video. It can now bring video in as another source of information for exploitation. We can bring in information from databases, we can bring information from web services, and the next speaker, Chris Tucker, will talk about how we're standardizing on those web services, so now these systems can be able to consume that information. But I want to talk just for a couple of seconds about big data. Big data is not a terabyte of imagery. Big data is not a large geodatabase. Big data is streams of information, machine-generated, unstructured information that we cannot go through. And the technology to deal with big data is the sort of massively parallel processing that is done by systems using Hadoop, Hive, NoSQL. And we now have to extend those sort of systems to allow that to be brought into our applications. We already see this. It's no secret that the US Army, the Distributed Common Ground System Army, has a cloud, has a Hadoop processing system, and actually it has it at Bagram Airfield in Afghanistan. So what we've been doing as a company for a number of years is supporting our biggest customer, which is actually the US Army, and supporting our multinational community, of which you are clearly a very important part, and looking at how our GIS supports special operations. And I come back to special operations will still operate in a military structure. There will still be battalions, there will still be brigades, even if they undertake missions in very small groups. So we have to be able to support data management from all of those different sources. We have to be able to support the intelligence analysis that generates the intelligence products that inform the planners. We have to then provide that information to the mobile users so that when the commander comes in and gets briefed and then goes to his helicopter or his vehicle or his ship, he has the same view of that information. And when he gets out of that vessel, he can operate in a dismounted context. Now, the other point I want to make here is that we all believe Moore's law is going to solve all of our IT problems, and maybe it will for computing and storage. Where our biggest problem today, particularly for special forces, is the network. We still have the tyranny of the network for our deployed forces who are operating on combat radio or at best satellite communications. And we have to look at not just a systems architecture, but an information architecture to determine what information we're going to send over those networks. And I would argue that the geospatial information we send over combat radio will be a message. And we have to design these systems so this information not only flows from the headquarters to the dismounted users, but remembering that our soldiers are our sensors, it has to come back. So in any of our activities today, we want to look at a net-centric environment because that provides the sharing. We need to consume the environmental data that was talked about this morning. We need to overlay that with our operations content and produce our staff products. And we need to share that. And increasingly, we need to do that through web apps, because web apps are delivered through Chrome, through Internet Explorer. They're not delivered through complex applications. But we have also got to get that information to the mobile users who may not have network connectivity. So we need to look at the workflow across the formation. And a brigade combat team is still a very good unit to look at for the sort of missions that they must conduct in their tactical operations center, their forward operating bases, versus what they'll conduct at small unit activities. And so we've looked at this with our customers to try and understand what are the functions that people have to conduct. So key to this is understanding the roles of the different users. And in many ways, you might think this is just a standard brigade. But what I would point out is that within the Special Operations Forces, the context of fires is different. Fires is not just artillery. Fires is also the non-kinetic, the non-artillery. So fires is also your information operations, your psychological operations, and how you're going to manage those, which gets into your civil affairs, which is actually your human geography. And one of the things to understand, again, no secret, is special forces have probably the greatest interest in human geography because they're the ones who are most exposed when they're in the community. So we're looking at these different roles and trying to understand what they each need. So we talked this morning about the operational environment, if you want to think of that as the foundation data. So we have to support vectors, rasters, imagery, elevation data. We've been doing that for years. The challenge actually now is to do that in a high-resolution urban environment, because we now fight the three-block war. Within 3 blocks, we go from conventional warfare to humanitarian operations. And so we have to collect and manage high-resolution urban data. And that's again why the US Army developed its own LiDAR-based systems in Iraq, because they needed that sort of information. That will be our challenge in future special operations forces. The intelligence process is complicated. There are very few specialists who really understand this. They get old like me and they retire, and we need to perpetuate their knowledge. So one of the things we've looked at is how do we support the ISR process by allowing analysts to perpetuate their knowledge so that we can rapidly generate helicopter landing zones, beach landings. We can look at incidents. But I also want to pick up on weather. One of the most important things we have to understand is the environment, and the environment is not just the battle space in the traditional context, it's the weather and the human geography. We have to support the operations process. Many times we'll lay out a vehicle checkpoint, or many times we'll have a target engagement area. We shouldn't have to reinvent how we produce those products and how we support the operations planners in conducting their missions so we can reduce the time of the OODA loop. But as I said, we have to get this information to the mobile users. Otherwise, it's intelligence for nothing. If we can't get that information to mobile users and we can't bring it back, then we really won't have supported our forces. So we have to have simple, lightweight, easy to use in-vehicle applications that when the special operations forces, when the operators get out, they can take that information in a mobile environment with them, receive reports, receive intel information, but also provide that. So I want to sort of wrap up this presentation with a couple of case studies. One is looking at NATO. NATO has effectively implemented an NSDI. They understand that in a multinational coalition like NATO, where information can come from many nations, they have to fight off the same map. They want timely, accurate, guaranteed geospatial information. They need this across all of their commands, because they have geographic commands with different geographic responsibilities. So their architecture, based on net-centric warfare, is to look at the concept of core services. And geospatial is a core service. It is provided as a common technology, a common solution into every command. And through that, they can then support their functional services, and you can see them all listed up there, but one of them is their Special Operations Forces functional service. So NATO is embracing an NSDI for multinational operations. Let's move quickly and look at the US Army. This is a graphic produced by the US Army that indicates their enterprise, their complete organization. You probably can't read it from the back, so let me make it simple for you. It starts with ingesting data from national sources, our National Geospatial Intelligence Agency, our Defense Intelligence Agency. It then is about managing that information in their Army data centers. It's then about getting that information into their Army command posts, supporting that information with their Army sensors, and ultimately providing that and enabling their mobile users, and by the way, bringing that information all the way back. So the US Army has understood the concept of a geospatial enterprise. They do not look at geospatial technology as ancillary that gets plugged in after the fact. They look at it as a foundation. So one of the other contexts that they refer to in the US Army is the standard shareable geospatial foundation. It's not one piece of software. It's not necessarily one technology. And the foundation is not purely software. It is looking at their information flow, their standards, their policies, their systems, to look at how the system will operate in a seamless manner. From a technology point of view, from a systems point of view, it starts with their ISR component of Mission Command, the Distributed Common Ground System Army. They then build their command and control systems using the Commercial Joint Mapping Toolkit, which is licensed to them through the National Geospatial Intelligence Agency, and now they are embedding that technology in their Joint Battle Command platform, which is their mounted and dismounted system. So they have a GIS technology that goes all the way across this world. And the other thing that they've done is they've broken down the barrier between G2 and G3, between Intel and Ops. And they now are looking at this Intel Ops synchronization To do that, we didn't have to change any of the technology. The technology already supported that. So a couple of conclusions. What you're seeing now is this geospatial platform is bringing this all together. It's bringing together intelligence, which is primarily collection and analysis. It is allowing that information to be consumed by operations, by planners. That information, that knowledge, can then be shared onto any standard client, whether that's a web app, a mobile app, a desktop app. And actually it works in a cloud environment. The cloud is already here. The cloud is in Bagram. The cloud is in our Intel centers. The cloud is everywhere. Okay? If you go and use open source, you will be using the cloud. You don't have to use a cloud, okay? But if you have problems of massively parallel processing or scalability in your systems, yes, you'll need a cloud. So the last slide in closing is that what we see is that GIS is enabling special operations. We are beginning to move beyond the family of systems that really is the third block on the right here. This network-based system where they couldn't talk to each other. We are now beginning to move to an information-based, an intelligence-based system where the net is the computer. And we can fuse this information across these systems and we can share it anywhere, anytime, any device, any network. So whilst this presentation, this theme was particularly special forces, I think, and I know from my experience, it is informed and it's informed by the work that we're doing with many of the customers, and many of the solutions will be the same, even if perhaps the timeliness is more demanding. Thank you very much.